Hi everyone. In this video we'll look at the AWS Storage Services, basically the databases and services where you can store files, data, etc. Right. So we start off with understanding and discussing features of S3, EFS, EBS, and then we move towards DB services like relational databases like RDS, Aurora, and then finally we move towards NoSQL database, the most important one in AWS, which is DynamoDB. Okay, and then we also a little bit look at something like Redshift, Athena and Glue. Okay, so this storage services tutorial we will divide into two videos. One we will look at S3, EFS, EBS and relational databases, and the other one, since at DynamoDB I am going more into detail because it's a very important service as far as NoSQL is concerned in AWS, and it's used a lot. Okay, so we look at DynamoDB in detail. That is why another video on DynamoDB and the other databases we just talked about. Okay, so let's start off with EBS. EBS is elastic block storage, and it is basically a network attached hard disk for an EC2 instance. Okay, as I have mentioned in the notes, it is attached to one EC2 at a time, and think of it in that way that if EC2 dies, EBS would still be there, but if the availability zone itself has terminated, then EBS also would terminate. Okay, so if you're looking for a database on a single EC2, you don't want to go out of EC2 to store your data in, let's say, a relational database like RDS or DynamoDB, then you can go for a EBS. Obviously, if it is inside EC2 only, the latency would be really low. So if you're looking for any of that, then you can go for EBS. Okay. EFS, it's a managed NFS file system that many EC2s can mount. Okay, it is multi-AZ POSIX file system. Okay, it's a shared upload library, so many EC2s can use a shared EFS to upload files. It's like it will have a directory structure, and it uses container management systems. And let's say if multiple EC2 instances are reading same files, then you can very well use EFS. It's a file system storage. Okay, moving towards one of the most highly used AWS services. I think if we have not used S3 is something which everybody would have used, even though full-fledged you would not have used other AWS services, but S3 is something which I think if you are a developer, you would have heard of it or used it anyhow. Okay, so it's an infinitely scalable object store, not a file system. Okay, it's an object store, and objects could be accessed via APIs. Extremely durable 11 nines. Okay, so S3 is extremely durable, and as we mentioned, it can be accessed via APIs, which means AWS regional endpoints. It's a AWS managed service. Now, what is the difference between durability and availability? Just to understand what we mean by extremely durable. Well, durable is nothing but it answers your question related to will my data survive failures, and availability is can I access my data right now. Okay, or you will give me a 404 not found. Okay, so available means the data is always available. Durability is whatever happens, will my data survive failures. Okay, and comparison, if you talk about durability, S3 is 11 nines, EFS is very high, EBS is availability zone scoped. So if availability is available, EBS is available. EFS we are saying very high, but S3 is definitely 11 nines. Okay. Now different S3 classes. So you have standard internal tiering, standard infrequent access, one zone infrequent access. You have Glacier Deep Archive and Glacier Instant Retrieval. Now depending on your use case, you can go for either one of the classes. Generally by default you use the standard one, which is best for the active data. As I have mentioned, there is no retrieval fee, it is multi AZ scoped, and retrieval time is in milliseconds. Internal tiering, so it is best used for unknown pattern. Okay, so the time could be milliseconds to hours in between any of this. Standard infrequent access is mostly for infrequent access for backing up data. So let's say you are not frequently accessing objects inside your S3, it's very infrequent or not regular, then go for standard infrequent access, because that would be more cost effective, because why you want to go for standard one when regularly you are not doing any calls to S3. So in that way you have to decide which would be more cost effective for your use case. One zone infrequent access, now this will be only single AZ. So basically durability wise it would be little bit lower than other classes, and this is more for recreatable data which is non-critical. Okay, infrequently accessed and non-critical. And let's look at Glacier Deep Archive. Now here the time to retrieve may be little higher, as it's a long-term archive. So let's say you are not frequently accessing that data, but you still want to keep it as stored somewhere, thinking that somebody may ask for it few years down the line. So you can go for this Glacier Deep Archive, which would be best case is long-term archive, as I already mentioned, but the time it takes for the data to be retrieved is 12 to 48 hours. Okay, because here time is not a constraint, right? So you are anyway using it like once in 6 months or even once in a year, right? So time wouldn't be a constraint for you in that case. And there is one more option in Glacier only, instant retrieval. So if you want the time to be lesser, by the way, all these from infrequent access have a retrieval fee. Okay, so it is multi-AZ anyway, Glacier instant retrieval, but it is faster. So the cost wise it would be on the higher side. So there is a trade-off, right? So if you are getting something, you have to pay money for that, right? So generally what happens is that there is the life cycle for data is generally you start with standard, then let's say that data accessibility becomes higher. If it is going from 31 to 90 days, then you go for infrequent access, and if it is greater than 180, like greater than 6 months, the data is there in S3 for greater than 6 months, and it gets retrieved once in 6 months, then go for a Glacier. Okay, 31 to 90 infrequent access. If it is 0 to 30, that you keep on, let's say at least a call is made every 30 days, then you still go have it placed in S3 standard. Okay, let's look at the AWS DB services. First we will start off with ACID and relational constraints databases, which are RDS and Aurora. For data warehouse you have Redshift, and for NoSQL you have DocumentDB and DynamoDB. In memory caches you have Elasticache, which could be either Redis based or Memcache based. Okay, RDS. feature wise, it's a relational DB service. Okay, it is managed by, it's hybrid managed by you and AWS, multi-AZ definitely. So it involves SQL joins, all the asset properties, and AWS manages backups and patching. Okay, AWS allows you to run various DB engines with respect to RDS. So RDS could have internally SQL Server, MySQL, MariaDB, whatever. The actual service would still be RDS. And yeah, best for asset transactions, complicated joins and queries, relational constraints in tables. You know, something very where you have foreign key, primary key constraints. You know, best for that kind of a data. And like order processing or banking transactions. You know, all that kind of data is best architected with relational databases, and it is not ideal for massive scales like millions transactions per second. Okay, if you need serverless architecture, this is not the one to be used. And if you need really low latency like millisecond latency globally, then definitely don't go for RDS. So my notes, you would always see the best scenarios and the not ideal scenarios. I have designed the course in such a way that we know what is the trade-off, what is this service best used for. I can keep on providing you the features, but if I don't provide you the best and worst scenarios, the notes which I have invested my time in is of no use, right? Okay, RDS could be RDS multi-AZ plus standby backup. So for high availability, you have RDS as a multi-AZ architecture, and also with standby replica. Now, what is the meaning of that? Let's understand that. So primary here handles reads and writes. Okay, there would be a primary active DB. Standby replica would be exact copy in another availability zone. Okay, so what would happen is the application would read and write from the primary DB. The standby would just be available in another availability zone, but app won't be accessing the standby. Okay, app just accesses the primary. Data replication is synchronous here from primary to secondary. Okay, and there is no separate endpoint, and the standby is not used for queries. There is no separate endpoint available for standbys to retrieve the data. Okay, when the primary fails, so it's a synchronous copy from primary to secondary. Okay, and when the primary fails, the AWS auto fails over, which means auto switches to standby, which then becomes the new primary. Okay, so you would have a downtime of 30 to 120 seconds if the primary is failing. So standby, as the name suggests, it's a standby in case the primary fails. Okay, it is not directly accessible to the application. To the application, still the primary is the point of contact, but synchronously you keep on updating the data into the standby, because as and when a primary fails, you would still want your latest data to be available in the standby, which then becomes the primary, right? Okay, read replicas. Now this is a little bit different from standby replica. A read replica is a read-only copy of your primary DB. In this case, the standby becomes the primary, which means the standby, after it becomes a primary, would be used for read and write both. Okay, as the primary fails, correct? But here read replica is basically only used for read, for scaling the read traffic. So let's say you have more reads coming into the application and writes are less, so you can have a primary with read replicas. for example, report analytics or reporting, and this replication is asynchronous, not synchronous. Each replica has a different endpoint. Here the standby doesn't have a separate endpoint itself. That's the major difference between read replicas and standby replicas. Remember that, very important. People keep on confusing these two. And now what would be a real world scenario? You would enable a multi availability zone on primary with standby in another availability zone. Okay, so that's how generally happens. So you will have a standby in another availability zone for fault tolerance, because if one availability zone data center is getting terminated or is failing, then you don't want the entire application to fail. So then what would happen is the standby would become the primary, and the AZ itself will change. Okay, and apart from this architecture, you would also add 1 to 5 read replicas in case the read traffic is scaling. So primary you would keep on using for writing, read replicas for the increased read traffic. You would have a load balancer which keeps on rotating the requests to each of the different read replicas. Okay, since they have a different endpoint, so application would directly access the read replicas, and the copy happens asynchronously, which means that your write which is happening to the primary, the call would return to the user, but the request would have just gone to the read replica to update whatever new update happened in the primary in the background, not in the same request. Okay, so that would just add a request to do the update, and in some time the update would happen. Okay, so it's a asynchronous replication. Okay, now what is AWS Aurora? We already saw RDS, which is the relational database system in AWS, primary relational database system. Aurora is also relational database management system, RDBMS, but it's, you can say, an optimized RDS, optimized form of RDS. Okay, it's a fully managed DB service and also a type of DB engine within Amazon RDS at cloud scale. So you can say that you have optimized your primary RDS to get you to basically improve performance and other data points, so that it helps you generally performance wise and other parameters. It's compatible with MySQL and PostgreSQL, performs faster. So here, as I was mentioning performance, so latency is faster than normal RDS. Okay, it provides less than 1 second of read replication latency for Aurora replicas in same or different AWS region. Now the read replication latency is less than 1 second. Can you imagine that? So in the same or different AWS region as well. RDS, it is a few seconds or minutes. So RDS, the replication time is on the higher side. Here it is very less, 1 second, less than 1 second. It is usually deployed as a DB cluster which contains one primary and multiple replicas for read. Okay, primary would be for read and write both. What is the best case scenario? You want high performance relational DB, go for Aurora. Multi AZ by definition, and global read scaling, read replicas. So if you want read replicas easily available, go for Aurora. If you have read getting scaled in your application globally, more reads, then definitely go for Aurora. So because you have read replica concept easily available here, and it is not suited obviously for NoSQL, small workloads and cost efficient. Now if you're looking for very cost efficient systems, then you would need to trade off speed with cost. So obviously lesser cost would be the normal RDS DB, because but yeah, the downside would be that the replication would be slower, and other things which we just talked about, the scaling would be little bit of an issue with RDS. Okay, yeah, that's pretty much about Aurora, I suppose. There is one more thing known as AWS Aurora Serverless. Now there are various apps which would have unpredictable usage patterns, right? So not all apps would keep on having a regular traffic, so there are some apps or products which would have the unpredictable usage pattern. So for example, extremely high at the end of the month, like month end services, or extremely high at the start or end, okay, and in the middle very low. For such situations, so it is very difficult to predict the application demand or to choose most suitable instances, because it depends on the time of the month or time of the year. So serverless is used for such applications which are unpredictable, which have unpredictable usage pattern, so that auto scaling up and down based on the demand can happen easily, and it can be readily used for serverless stack with application containers running AWS Fargate and DB on Aurora serverless. Okay, so if the AWS serverless stack is there, like Fargate, having ECS running on Fargate then definitely Aurora serverless is a good addition in terms of the DB side of things. And there is let's say there's a use case of converting monolithic apps to microservices architecture, then definitely serverless is something you can look at, Aurora serverless. There is one more concept known as Amazon Aurora Global DBs. It is designed for globally distributed apps, allows a single Amazon Aurora DB to span multiple AWS regions. Okay. The recovery point objective is 1 second. Recovery point objective is 1 second. Recovery time objective is 1 minute. One of the best. Recovery time objective is 1 minute only. Generally RTO takes several minutes, but here with Aurora Global DBs, it is 1 minute. So it allows Aurora DB to span multiple regions. So if you want a globally distributed app where you have users from various different regions in the world, like from India you have more users, and you have a lot of users from the Americas, North and South America, and also from Europe, then go for Amazon Aurora Global DB. Okay, I'll stop this here and I'll see you in the next one. Thank you.